Hello, I'm Sai. Today I'm going to present about a literature survey on exploration of power efficient network on chip architectures. In this presentation, I will briefly discuss about NoC and why do we want power efficient architectures for designing a NoC. And later in this presentation, I will be talking about various power efficient architectures which are implied in the NoC. And I will be concluding the presentation with the further work. NoC. NoC is a communication system on an integrated circuit which happens between the intellectual property cores in a system on chip. So every day many core chips are emerging as architecture of choice for providing efficiency. So these on-chip networks plays an important role in achieving high power efficiency and performance. These interconnects will require specialization to meet power and performance objectives. So the emerging architectures are based on the NoC concept. The research is mainly focused on the power efficiency and the fast operation of switches. Let's have a look at the architectures. ReNoC, Reconfigurable NoC Topology. Here we can achieve low power consumption in a NoC by exploiting the application behavior which is going to run on the system on chip. The option is to generate a heterogeneous application specific topology which will match the communication requirements. The ReNoC will be combining the packet switching and circuit switching techniques and which is making it possible to create application specific topologies in a general NoC based platform. In order to achieve a fairly low consumption value, the router must be chosen in such a way that the bandwidth and features do not exceed the requirement of the application. Here, the topology switches are meant to be configured infrequently, such as once every time when the circuit starts. By using this design, 56% of the power consumption is decreased. Low power switch design. So this is a design which uses low power switch for achieving efficient network on chip. Here the arbiter will be having the priority and the grant circuits. The priority matrix will be having the priorities of the request, and the grant circuit will generate signals when there is a channel available for that. So in this circuit, as we see, only one part is activated in the design. So here as we observe, there are two types of transistors which are M1 and M2. Here the transistors M1 will disconnect the input circuit from the supply voltage during the output mode. Similarly, the transistor M2 will disconnect the output circuit from supply during input mode. By oscillating in this way, a considerable amount of power is being saved, which is observed as 33% reduction. Resin, reliability aware and energy efficient synthesis of NoC based MP SOCs. In CMOS technologies, NoC is increasingly prone to soft errors. These soft errors can be tackled by employing fault-tolerant schemes, but the fault-tolerant schemes introduce severe power dissipation which increases chip power budgets. But this resin employs a nested genetic algorithm. The main concept of this algorithm is to guide the mapping of cores onto a die. So here by using this design we have to achieve two goals, which are core mapping and NoC synthesis. The outer loop does the core mapping and the inner loop does the generated core mapping from the outer genetic algorithm. Here, by using this type of design, a power efficiency of 14.5% is a reduction in power efficiency is observed, and the fault tolerance has been increased to 90%. RFI, radio frequency interconnects. An alternative way for achieving good power efficiency is to propagate analog waves over an on-chip transmission lines. This RF interconnect is a promising solution because of its compatibility, low power consumption, and thermal insensitivity. The transmission in this RF interconnect is actually done by the electromagnetic waves over a set of transmission lines rather than using the traditional voltage signals. This carrier wave is sent continuously along the transmission line instead. So here, as we see from the mesh network, there are few shortcuts which have been represented in the figure by the arrow marks. Here these are called the adaptive shortcuts. This selection of shortcuts is made to match the underlying architecture, as because this RF interconnect will be reducing power by using adaptive reconfiguration. So based on the shortcut selection, each component will be tuned to a frequency to implement the shortcuts. When the network is growing, we can actually switch from the XY routing to the shortest path routing. By reducing the bandwidth to 4 bytes, we see a 72% reduction in power consumption by using RF interconnects. DIMNOC, a proposal to tackle the dark silicon problem from the NOC's perspective. Here, instead of using the conventional buffer, this DIMNOC uses a drowsy SRAM buffers and STT RAM buffers for achieving power efficiency. Here, instead of completely shutting down the on-chip components, there is another option called DIM silicon, where the components are operated under perfectly clocked conditions. Here, as we see from the circuit, the drowsy SRAM, the router operates between two states, which is on and off. So this router, as this is operating between the two states, it is actually operating in low power consumption state, which allows to retain the data but doesn't give access to write operations. As voltage is higher than off condition but lower than the on condition, the data transfer can be done power efficiently. We can see the STT RAM cell, which allows a latest technology called which adopts a latest technology called non-volatile memory. This has negligible leakage, and so the peripheral circuit becomes the dominant leakage consumer in the STT RAM. These STT RAMs are usually employed in the higher level virtual channels, where these STT RAMs can accommodate heavy traffic, which will help in avoiding costly writes. Banked buffer. In the banked buffer, the SRAM and STT-RAM are logically interleaved, but physically organized as separate banks. The incoming flits will be written into appropriate banks by going through a bank selection multiplexer. The flits will be written in parallel into the respective RAMs so that they can complete the two-cycle write operations. From this DIMNOC, we can see that the experimental results saying that an energy efficiency of 30.9% reduction is seen. Related work. In this work, I have discussed various architectures which achieve the required power efficiency. This power efficiency can be achieved by careful optimization at different levels, such as component, circuit, and architecture level. Grouping of different techniques, each aiming at various levels, is expected to be the most suitable approach in designing a power efficient interconnection network. A few more architectures are being discussed in the literature survey, which are the LUMI-NoC, minimally buffered deflection routing, and cache coherent NoCs. Future work. Future NoCs will be highly advanced with concepts like photonics, cache coherence, adaptive RF interconnects, etc. being involved. Most of the server chips are increasingly relying on large number of low complexity cores to achieve power and performance scalability. Also, insertion of fault tolerant mechanisms in NoC routers is one of the best approach to minimize the energy consumption of a NoC. Thank you. These are the references which I have used for my literature survey.